In this video, we are going to see about the orbital elements. The main purpose of determining the orbital elements is to discriminate one satellite from another and the position of the satellite on the current timings and the amount and the direction of the perturbations. These are all the parameters which can be derived from the orbital elements. So we can define orbital elements as a set of mathematical parameters to describe the satellite motion. Overview on orbital elements. There are 6 orbital elements. These are called as Keplerian element set. The first one, it is semi-major axis denoted by A, eccentricity E, mean anomaly, and amount of perigee, inclination, right accession of asymptotes. About the first one, semi-major axis, it is used to determine the size of the satellite's orbit. On basic, there are 4 different sizes of orbit in satellites. The first one, it is low Earth orbit, that is approximately lies above 1,200 miles above the Earth. Medium Earth orbit, which is around 12,000 miles from the Earth. High elliptical orbit, which are from several hundred miles, and geostationary orbit, there are approximately between 22,300 miles from the Earth. So these are different sizes of the orbits. And second one, it is the shape of the orbit. The orbit, it may be a circular or not circular. Not circular in the case, it may be of an ellipse. This elliptical shape of an orbit determines the eccentricity. Based on the eccentricity, the orbits are classified as circular orbits and elliptical orbits. Circular orbits, it has some characteristics like constant speed, and it runs on the constant altitude. And elliptical orbit, it has different speed, different altitude, and asymmetric ground track, because since it is not circular, it has asymmetric track. And there are some application missions on circular orbits like geosynchronous communication satellites, GPS. These come under applications of circular orbit. And in elliptical orbits, applications will be like missiles and deep surveillance satellites. These come under the elliptical orbit applications. So as I said, the eccentricity that determines the shape of the orbit. If you see the first one, it is eccentricity is equal to 0.75. The orbit is somewhat elliptical, and if it is 0.45, it is the eccentricity is like this. And if it is E is equal to 0, the eccentricity is 0. It is in circular orbit. And the third parameter is the inclination that determines the angle between your orbital plane and the reference plane. Usually the reference plane, it is taken as an equator. It says about the tilt of your orbit, and here it is an equatorial plane, and how much it is tilting. This inclination, this tilting blue color line, it says about the inclination of the orbit. If it is 0 degree of inclination, that is I is equal to 0, it is equal to the orbit. Orbit is you are on the equator. 90-degree inclination, you are on a polar orbit. This is about inclination. So for I is equal to 0 or 180 degree, your orbit is on the equator. So inclination between 0 to 90 degree, it is prograde orbit. And if it is I is equal to inclination is equal to 90, it is on the polar. And I between 90 to 180 degree, it is retrograde orbit. The fourth parameter, it is right accession. The right accession, it is the angle between your fixed direction to the ascending node. Here the fixed direction or the fixed point in the space, we take it as called as the first point of Eris. And how much tilt your orbit is from the fixed point of Eris, that is called as the right accession. This right accession will be measured in degrees from 0 to 360 degrees. Fourth one, it is the augment of perigee. Perigee, we know it is the closest point of orbits. And the augment of perigee, it is the angle from the assessing node to the perigee, or we can take it as a measurement of fixed point. It is fixed point for Eris to the perigee. So the perigee, here it is the orbital value. So from the center to the shortest distance, it is the perigee. From the center to the largest distance, it is the apogee. So from the fixed point of Eris to the perigee, it is the measurement of augment of perigee. So this red color line. This perigee that determines the orientation of your elliptical orbit. And the next parameter is the true anomaly parameter. It is the what to say? It is a measurement of fixed point in the space to the actual location of the orbit. It says about the position of the orbit at a given time. It is the angle from the perigee to the satellite's current position. So this is perigee, smallest distance is the fixed point. This is smallest distance perigee. So this is the satellite. It is the current position of the satellite. So it gives the angle from the perigee to the current position of the satellite. So the satellite is a moving one. So the true anomaly parameter will varies from time to time. So suppose your satellite is here. If suppose your satellite is here, the true anomaly will be between this position to the fixed point position. Suppose here your satellite is here, it is between the satellite to fixed point, perigee point. So true anomaly parameter will changes over time. This is a summary of the Keplerian elements. From the beginning slide, we are seeing these Keplerian elements are used to determine the size and shape of the orbit and the current location of your satellite. So there are six orbital elements which belongs to the Keplerian set, which are major axis, semi-major axis A, that is used to describe the size of the orbit. We know that eccentricity, it determines the shape of the orbit. If the eccentricity is equal to 0, this orbit is in circular shape. If it is some 0.4, 0.45 or 0.75, it belongs to the elliptical orbit. And the mean anomaly, it gives about the current position of the satellite. So true anomaly, it gives about the current satellite position. And augment of perigee, it related to the orientation of the eclipse in the plane. It is the angle from the ascending node to the perigee. Okay, then it is inclination, how angle of inclination, how tilt it is the orbiter's value, that is the tilt of the orbit. And sixth parameter, right assertion of the ascending node. Right assertion, it gives about the orientation of the next ascending node. That is ascending pass, next pass. Okay, so this 6 parameters will define about the orbital elements.